Alright, hello everyone. This is a tutorial on how to make a simple water shader in both Shader Forge and Amplify. So let's go right ahead and make a shader, shall we? Shader Forge, new shader. Doesn't really matter. PBR, whatever. Just call it water test. We don't need metallic, so we're just gonna hook up a 0 value node up there. Glossiness. We might need, well, we will need, and normal map. Basically just delete that and actually delete all of those. So let's start out with making some form of color that would actually look like a watercolor, right? So let's go ahead and do that. Let's make a couple of color nodes. Two color nodes, call one of them color deep and the other color shallow. Now to blend two things together you need to lerp them. So lerp, put one into A and the other into B. Now you could simply just use a switch or a value to switch between both of these colors, but we're gonna have to try and make this sort of gradient effect. Those strange bloom effects right there. this gradient from one color to the other, right? And that thing is called a Fresnel. So we could hook it up like that. Well, actually we can. The example that I have, the cheat sheet that I have, used to have another thing hooked up to it. So we're just gonna do it like this for now. Alright. Normal direction. Perturbed, and already if we like, this is white. Oh wait, the deep should be black and the shallow should be white, and hook that up to color. Now you can already see that it has the gradient effect. The glossiness works, right? Yeah. And this ensures that when we have normal mapping applied to the shader, we could sort of affect the Fresnel with the normal map. And this is the exponent of the how much of the gradient is going to move out towards the edges, right? So if we hook up a value and set it to like 4, compile, now you can see it's really extreme. Let's just clamp that off. Clamp. Do it in simple. Clamp simple. There we go. Minimum 0, maximum 4, sure, and set it to 1.336 because that's the Fresnel value of water, I think. Can't quite remember. Let's call this Fresnel color Fresnel. Simple enough, right? Yeah. And in here we'll just move these around in the properties. So once you make a material, they will show up one after the other properly inside of the material. Let's go do that. Material. Where was this created? Shader Forge water test. Okay, good. Shader Forge water test. Oh, right. Since I already have these colors in another shader. You could go ahead and sort of try and screen cap or follow the colors that I'm going to. There it is, the color picker, because I found these colors in another tutorial ages ago and they sort of look really good. So this will be the standard color in this shader, and it will follow every material. It sort of will be the standard colors. You can change them later, but since we sort of want this color because they do really look nice. So you could already see that we have a good, well, the colors of the water look quite nice. Looks almost tropical in a way. But there's no water ripples. So let's go make that, and by making that we need to start using normal maps. So let's create a texture 2D. Let's actually create two, because we're going to affect two of these and blend them together sort of using a texture asset. So we only need to hook up one normal map onto the object, so remember to set it to bump and normal. Let's hook up a lerp. Was it? Let's just take a look at my cheat sheet. Yes, it was. Now you could already hook these up like this and like a slider, like so. Let's just move these closer to the actual material, main material thingy. Hook it up to normal and hit compile. Now if we find a water normal map, well, it doesn't really do anything, that lerp thingy that we had. Let's call it normal blend strength. Let's call this normal map. Compile. All right. Well, we have the the normal map at least, but it's not moving. How do we move a texture? Well, you use a panner and a time or something similar. Okay, let's just show it off how it works. UV and UV. Hook that up like that and like that. Now it should already start moving. And since it doesn't, this normal blend thingy that we hooked up, both of these values into each of these texture 2D nodes are the same. It won't be any different once we switch between one of those. So let's make another panner, and let's use this one instead. The time normal instead of divided by 20. Hook that up there, hit compile, and if we move this now, you could already see that it's moving quicker. So if we, you can see we have two layers moving, but it doesn't look quite good. Not exactly what we want. So we're actually not going to use panner. We will use time. We won't use this one because we're, well, the problem here really is, if we just isolate one of these, is that once we move this around, the texture applied to it moves with the object, while for models and different objects it might be what you want, but since this is water, you want it to sort of be applied in world scale, in world UV. How do we do that? To compile again, just to remove that. Well, we'll start sort of centralizing the code right now by doing these set, which sort of makes a variable within the material or within the shader. We'll start using those instead of just like manually hooking up the nodes into different things. So let's start off by making the UVs that we need. World position, and the UVs we need is the X and Z. It's because that's the above view of the world. If we choose Z instead of Z, it'll start applying it from the side instead of above. So let's use an append node to use both of these. Couldn't just use that because then you get the Z value also. And the cheat sheet shows me doing a divide because now we're doing the scaling of the UVs. So UV scale, set it to 1. Now if we change this value, once it's hooked up to a texture, it will scale naturally. Now let's hook that up to a set node and call it underscore world UV. Simple enough, right? Yeah. And let's now start using a get node and select the world UV, hook that up to those texture 2D nodes, hit compile. And let's select the water shader. Now you can see it's scaling properly in world space instead of object space. And if we move all of these around, you can see the material or the texture stays in world space. So you can actually move these planes around, and the actual coloring and texturing stays where it should be in world space. But we're not going to do that, use that just yet. But there you go. Alright. We will use this right about now, because now we're going to separate these two from each other by sort of making their own UV sets from this one. Actually, we can start making another set node and call it, well, let's just call UV1, and another one called UV2. So how do we make these two individual UV sets move? Well, we already used the panner, which is basically just an add node, which you can sort of control in the individual axes of the U and the V. But we're not going to do that because, well, as you can see, once you hook this up, you can't exactly affect these two values from this node. So the easiest way of doing it is well, actually there's no value 2 node, so we're gonna have to use a value 4 node. We will get these two Z and W axes that we won't use, but at least the X and Y axes are there. Let's just call it UV1 emator. Let's make another one, value 4, call it UV2 animator. Simple enough. So now that we got that sorted out, I just noticed within, oh right, never mind, just a fluke. Now we need to separate the two axes that comes from the world UV node, and we do that by using a component mask. Pick that up, set these next one to G, R and G. Now we have separated the two values, but we need to do it once more because we have two sets and we need to affect them individually. So like that. Now to move these, or actually to animate these, we need to use a time node, one we created earlier, but whatever. And let's hook those up to a multiply node. Actually, two multiply nodes. I'm gonna just move these out of the way. Alright, so the first one, we need to multiply the x value. Second one, we need to multiply the y value. And use the time node on the second input on the multiplier. Now we can control how much of the time in the U and V channels. But how do we move the channels? Well, we could use the panner, but as I said, you can't really sort of affect these two values from within this node. So we basically just use an add, or two adds actually. And since we have two component masks, we can hook this one to do this one and this here, R into there and G into there. Now we have two separate U and V sort of channels that we've moved depending on how much of these we sort of set to whatever we want. So if we set it to 1, now it will move in one direction in world space. Set this one, it will move the other direction. So with these ones, once we make that. But how do we combine them again? Because now we've already made a UV set for this one. Well, you use another append node. There we go. And we just got to do that again for this one too. Add. So like this, and then multiply down here. Need to multiply the x value and the z value. No, the y value by the time divided by 20, time divided by 20 again. Hook this one up to this b value, and this one up to the other b value. Append node, connect them together, and then into the UV2. Gotta make it clean and tidy, right? Alright, goody. Now we also want to individually scale these two, so we can have one of the normal maps be a higher detailed version, while the other is a lower detailed version, so we have two layers of smaller waves and one with big waves. And to scale something, or to make it smaller or bigger, we need to multiply it. Divide makes it bigger in bigger values, multiply makes it smaller in bigger values. Value, that up there, and another value, hook that up there. This one into there, and this one into there. And this one we will call UV1 tiling, and the second one we'll call something else. Now we'll call it UV2 tiling. Pretty predictable. Whoopsie, there we go. Almost made a mistake there. So now we already have the UVs we need, so now we just need to make a get node, UV1, get node, UV2. Hook those up, put them there, UV2. I'm just moving these around to make it simpler to affect them afterwards. Alright, what else did we need? Yeah, alright. Let's hit compile and see how we affect them now then. So now we have UV animator. If we set this one to 1, you can see it's moving. Hooray! And it's moving because the time node continually sort of adds to its value, and since we're affecting that value by these, so we can sort of set it, see, sort of moving in different directions. And the reason why we do hook it up to a value 4 is now it's even easier to affect using scripting. If we wanted to script the direction that it's moving, we could easily do that. But if we make 2 different value nodes, it'll be a bit difficult, or actually wouldn't be more difficult, it would just be sort of tedious to individually script the directions. So if we go back to 0.5, set the scales to 1 and 1, and UV scale to 1. Now one texture is 1 meter across. Set the UV scale to 2, it'll be 2 meters across, or 2 units. But a unit in Unity is a meter, so set it to 24 again, or actually 12 or something. Now if we scale the second one, the UV2, to like 2, it'll be smaller. As you can see, it's smaller than this one. And if we start animating these, as you can see, it's already sort of moving in different directions and sort of affecting each other to create a more naturally moving water, sort of. But how do we affect the strength of the normal map? You can't do that within just here. What if we multiply this? Well, you'll start getting strange values, so actually what you need to do is to separate R and G and set B to a constant value and multiply these R and G values. Since B is, well, it's calculated in real time, sort of, so we only need R and G. So let's do that. Let's make an append node for each of these. Hook those up, and we can multiply that by a value. Let's call it normal map 1. No, just normal 1. Normal map 1 strength. And let's hook that up to multiply. Was it? No. The append node comes afterwards. There we go. Component mask, that's the one we needed. Actually, it would be exactly the same though. Now let's use a static value, set it to 1, and hook that up to there, and this one there. And then into the lerp. Now we need to do that again for the second texture, second normal map. So component mask. Well, actually, you'll figure this out on your own, sort of. This is just doing the exact same thing second time. Normal map to strength, and another append node, and look. Now once we start affecting these, it'll actually change the strength with the amount of normal mapping on the object, on the shader. Let's just sort of centralize the entire thing, set, call it normals, I don't know, or normal mapping, I don't know, get normal mapping, set it to normal. That's a lot cleaner. We can do the same thing with the colors, but so little, we don't need that. There we go. Was there anything else we needed to look at? Nope, I think that's all. This is the most complicated thing within the shader, because you have to sort of logically add and multiply a time node to properly move, individually move the axes within the UV channel, the world UV channel. But once you've made that principle, you could sort of get the rest, I suppose. Normal map. Where did I put that? There. Compile and there. As you can see, it's properly setting the strength of the normal map, of the individual normal map actually. So if we set it to 0.5 and something like that. Now it's moving fairly realistically, and you could add tessellation and whatnot to the object and displacement mapping to move all the vertices to make it look even better, I suppose. But it looks nice already. There's no need to make it more complicated. And since we're not, well, we actually could do transparency by hooking up something to the opacity channel and start affecting it by the normal maps and all that. But that's a video for another time, I suppose. So that concludes part 1, I suppose. Now let's go straight to part 2, which is doing the exact same thing for Amplify. So let's do that. Let's create a new shader, Amplify shader. Let's move that into view. Now with Amplify it's actually quite simple, since a lot of the things we have to force within Shader Forge is sort of already there within Amplify. Amplify water test, and let's call it Amplify water test. Alright, hit compile just to make sure it's saved, and let's open up this one as well just to show how it will look afterwards. Yeah, it's pretty simple actually. But what is all this? Alright, that's the parallax thingy. I tried out with parallax mapping within a water. Looks okay, I guess, but you could basically just ignore it and go straight for just using regular UVs instead. Alright, let's start out by creating a world space. No, wait, world. What is it called again? World position. Get. Doing something so many times you forget. You start questioning, is that a real word? Append, and let's use X and Z again. Divide that. Alright. Keep forgetting. The append node you have to manually set which one it's supposed to be. value. Probably call it UV scale. Bam bam bong. Variable register. That's the same as set variable. Let's call it world UV. One of the things which is quite nice, which is very Unreal Engine-esque, is the fact that you can add comments. That's quite nice. World UV. There we go. Now let's make the texture maps. Texture object. There we go. And these are unpack normal, set it to bump, call it normal map, lerp, how do we, there it is, lerp. We don't need to do the whole multiply and constant one within Amplify because it already has a scale thingy, so we could just make them like this instead. Normal map 1 strength. Normal map 2 strength. Hook that up to scale, hook that up to scale. And make another one. 1 normal blend strength alpha and color lerp. Variable, register variable, variable, not valuable. Well, the variables are valuable. Ha 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 ha, stupid. Normal map. Get and whoops. Fresnel. Normal, that's actually, we need to do a get variable, whoa, no, get variable. And okay, normal map up to that. There we go. Color. Get color, hook that up to albedo. Normal map. Color. Alright. Now let's do the whole UV channel thingy. Alright, so let's start out by getting the UV world UVs. And let's create a time node. That's the, no, keep forgetting which one it is. It's time parameters, there it is. And how do we do that again? Right. It's just using panner, right? Because the panners within Amplify, you could set, as you can see within internal data, you can set all of these yourself, and it's within the whole, it's within the material too, which is quite nice. Speed, that's the no, that's this, alright. I get confused. Time. Panner. Another one. Time. UV. UV. What else was it? Tiling. Right. Multiply. By values. UV1. Tiling. And guess what? UV3 tiling. No, UV2 tiling. Gotta spice it up. Spicy. Speed. What was that again? That was... Right, that's the whole animate thingy. 2. Property. 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 Where do I place them? Right. Just like that. Forgot to turn on the colors. Whoa. Now it's all yellow. We can easily follow the lines. UV2 animator. Let's just call it animator instead of animation speed. Oops. UV2, no, 1 animator. And speed and speed. Right, you can't get the whole internal value. That's right. I forgot. That's why I made these. It's already sort of a mess here. Let's just fix that by moving these around. Wait. Right, forgot to add the multiply. No, I did. I just hooked it up to the wrong way, the wrong thingy. Could you tell that I'm tired? Probably. Whatever. No. God damn it. It sort of makes these online references pop up and it's annoying. There we go. Now we have... That's all. Alright. Variable again. Register. Variable. Variable. This is UV underscore UV1. This is underscore UV2. Now all we need is to actually make them. Alright, get variable UV1, get variable UV2. Like so. And what else was there to do? Lens strength, we already have that. Yes. And instead of making that its own thing, just put it for now, color, right? Right, that's the goddamn parallax mapping. I think that was it. Let's check it out. Hit compile after we do this, UV1 and 2. Hit compile. Move you out of the way. Set it to Amplify Portrait Test. And there's something I forgot to do. Apparently. Oh, right. Property. Just get the whole colors again and set them to property color deep color shallow. Hit compile. Alright. Is it any different now? It is. Well, it's working, that's for sure. The blend is not set to property. There we go. Nor is there a smoothness. Property 1 and smoothness. Call this glossiness. Hit compile. There we go. And of course it puts it up at the bottom of the whole properties thingy. But yeah, now it's working. So now we have two water shaders, one made in Amplify and one made in Shader Forge. You could already sort of within Shader Forge and Amplify add different effects like depth blending when you have objects within the water sort of blend seamlessly within the objects and all that, and add different foam effects within that depth blend and all that. But I'm not gonna do that for this test because it's only to show that it's quite simple to get water, and the only reason why the two Shader Forge and Amplify shaders are different is because of that Fresnel thingy. If I add a, I think it's power. Let's see. Let's add a 1.1, no 1.336. Let's see. Yeah, I think that's it. Was the only difference. Go to Shader Forge water test. Yep, that's it. That was the only difference between the two waters. The whole having this color strength. Right, that's what I called it earlier, I think. Alright. Hope you like this quick tutorial. This tutorial on both Shader Forge and Amplify on how to make water shaders. It's quite simple. The whole animating thing is only, well, using adds or panners with Shader Forge. Using panners is iffy at best, so you might as well just separate the whole axes of the UVs and add them with different values multiplied by time. So yeah. Happy forging and happy amplifying, I suppose. Goodbye.